Hi, welcome to the notes for 3-1. Today we're going to focus on horizontal and vertical stretches. We've done vertical stretches in the past. That's when we multiplied our a times our function. Today we're going to be multiplying a times the x value within the grouping symbols of our function. Okay, that's going to give us our new horizontal stretches and compressions. So this one will give us vertical stretches and compressions. And then this one should give us horizontal stretches and compressions. I'm not writing compressions because I'm trying to cut the video time down just a little bit. So we're going to learn, this is the new one that we'll be looking at today. This one we should already know how to do. Let's move on. So review, shown below is the graph of y equals g of x. Sketch the graph of y equals negative 1/2 g of the quantity x plus 1 minus 3. So we've got some transformations happening. Let's start out with our y is equal to g of x. All right, that's our graph on the left. And all we're going to do is just take some points from that graph. We'll use negative 2, 0. We'll use negative 1, 4. We'll use 1, 0. And then we'll use 2, 4. And those points will help us with graphing our new transformed function. Let's create an input-output table on the other side. And let's look at our function to figure out what's actually happening. You'll see in the function we have a negative 1/2 times the g. That's like our stretch factor, right? So this is going to give us a vertical compression, and it's going to flip our graph. This one is like our k value, which is going to give us a vertical shift down 3 units. What we see in here affecting x, it says +1, and I think everybody knows that's our h value, and it's going to shift our function to the left one. But let's look at how we can come up with these new points using these. So our a value, when it's on the outside, and that k value will always affect our y values. So we're going to say negative 1/2 times y and then minus 3. Since we have a +1 inside of here with our x, remember we're shifting it left 1. That means that our coordinates are all going to lose 1. We're going to subtract 1 from each of them to move it to the left. So that's the one that has like that opposite or inverse effect on the coordinates. So you see x +1, oftentimes you think we're increasing, moving to the right one, but really we're moving to the left one. Now to find our new coordinates, all we're going to do is take our x values from our original table, and we're going to substitute those values in for x and then simplify. So I plug in negative 2 in there. So negative 2 minus 1 gives us negative 3. Negative 1 minus 1 is going to give us negative 2. 1 minus 1 gives us 0. And then 2 minus 1 gives us 1. Now you're going to take your y values from your original table and you're going to plug them in for y and then simplify it. So when I plug in 0 to start, negative 1/2 times 0 minus 3 is negative 3. 4 times negative 1/2 is going to be negative 2. Minus 3 gives us negative 5. And you'll see we have another 0 and 4, so they're just going to repeat themselves just like that. Now we can take the time to graph our transformed function. Our first point is at the point negative 3, negative 3. Our second point is at the point negative 2, negative 5. The third point is the point 0, negative 3. And our last point is the point 1, negative 5. And I think you'll see here this function is going to come up from the top actually and go down, bounce back up, hit it, and then go back down. So you see that's the effect we've got, right? We can see that we've got a vertical compression because those humps aren't nearly as high as they normally are. And then we've got that negative 1/2. It looks like we've flipped it, so now it goes down. Okay, and then it's been moved down 3 units below the x-axis. All right, let's look at another transformation. Okay, so our first transformation that we are learning today is y is equal to f of a times x. All right, and we're going to use our parent graph y is equal to the square root of x to help us figure out this function. So, first of all, y equals the square root of x. We know that 0, 1, and 4 go in nice and neat. So the square root of 0 is 0, the square root of 1 is 1, and the square root of 4 is 2. We're going to plot that parent graph right here. And now we're going to explore what is changing when we do y is equal to the square root of 2x. So as we look at it, right, the only thing that's happening is we're multiplying x times 2. So our a value out in the outside would be like 1, and then our k value would be 0. So nothing is happening to y. And since nothing is happening to y, we can take these three values that we've already got and just go ahead and transfer them over. Nothing is changing in terms of y. For our x values, let's use our function to figure out what the inputs would be. We said y is equal to the square root of 2x. Now, if I know that this output is 0, I'm going to substitute that in for y, and then we're going to solve it to figure out what the input would be. So we're going to square both sides. We get 0 is equal to 2x, divide each side by 2, and we know that 0 equals x. So even after all those transformations, right, our first point is still at 0, 0. Now let's do the second point. Let's take that 1 and let's plug it in. We're going to say 1 equals the square root of 2x. Again, you can square both sides to get 1 is equal to 2x, and then we'll divide each side by 2 to get x equals 1/2. So that is the value of x. And then you can do the last one there, right? Just take that 2, plug it in for y. So you get 2 is equal to the square root of 2x. We square both sides and get 4 equals 2x. And then we divide by 2, and that's what x ends up equaling. So we'll put our 2 down here. Let's go ahead now and look at plotting those points. We have a point at 0, 0, a point at 1/2, 1, and a point at 2, 2. Well, I think it's kind of interesting to see here that, we took it and we multiplied our x value times 2, but then our x values went from being, over here at 0, 1, 4, they started changing when we moved them over. So originally, right, we multiplied by 2. That was in our equations. But the effect it had on our x-coordinates is that it went from 0 to 0, 1 to 1/2, and then 4 to 2. It was like they each divided by 2. So our x-coordinates cut in half. Look at your graph. The first one is 1 full unit, right? That point 1, 1 is 1 full unit from the y-axis. But then you've got, on our new graph, it is half as much. For the next one, you'll see that when we plug in 4, our output was 2, right? But now we've shifted that point back, and we've got our point at 2, 2. So what we call this is a horizontal compression. This is a horizontal compression. Okay, so we're compressing our graphs, so they're getting more narrow in terms of from a horizontal standpoint. All right, so what's the rule that kind of goes with this? Well, if our original points are x comma y, and we're trying to use a horizontal stretch or compression, what we're going to have to do here, if it's a times x here, then it would have to be x divided by a in our table or in our coordinates. Nothing's happened to y, so we'll leave it just like that. So just to kind of recap, when multiplying x by a in the equation, then divide x by a in the table. Let's move on. So the next one, it says, let's look at y equals f of x divided by a. So it's the, the opposite scenario. We have, instead of a being multiplied times x, we're dividing it. Let's see what impact that has. So we're going to start this one the exact same way. We're using the same parent graph, y equals the square root of x. So 0, 1, and 4. Square root of 0 is 0, 1 is 1, and the square root of 4 is 2. We'll go ahead and plot those on here. And heck, I think we could fit in there 9, 3 as well. Let's go ahead and put that on there. And so with this one, we went from just the square root of x to now the square root of x divided by 2. So with this one, we're dividing by 2. All right, so nothing is happening outside, so we know our y values are going to remain the same. We have 0, 1, and 2. To get our x values, let's just do what we did before, where we took this 0 and we plugged it in for our y and then solved it for x. So we had our original. We'll say here 0 equals the square root of x divided by 2. We'll square both sides to get 0 equals x divided by 2, and then multiply both sides by 2, and x is still 0. The next one, we have y is equal to, let's take out that y, and let's just go ahead and put in our 1. So 1 is equal to the square root of x divided by 2. Square both sides, 1 squared is 1. Square root of x over 2 squared is x over 2. And then when we multiply both sides by 2, we're going to get 2 is equal to x. So we got a 2 right there. And last but not least, let's go ahead and do the last one here. So we did 0, we did 1, now we'll do 2. We'll say 2 is equal to the square root of x over 2. We'll square both sides to get 4 is equal to x over 2. Multiply both sides by 2, and we get 8 equals x. So there is our 8. Let's plot that one in red. So we'll say 0, 0, 2, 1, and 8, 2. Okay, so looking at that now, right, if we think about our original graph was going from 0 to 1, it was 1 unit long. Our new graph here is twice as long from the y-axis. Same thing happens here. We're 4 units away from the y-axis, and then our new graph is actually going to be 8 units from there. So we're going to refer to this as a horizontal stretch. This is a horizontal stretch. And the rules that will follow here will be x comma y, and then when we horizontally stretch it, remember what you're seeing here is x divided by a. Well, when you see x divided by a, we know then we're going to do the inverse of that. We're going to do a times x and then comma y. So when you see it, you're dividing by a in the equation, you're going to multiply by a in the table. Okay, so down here, okay, up here we divided by 2. Now we are multiplying by 2. I want to make sure you have that in your notes. So multiply by 2. All right, let's look at this last new little rule. Let's look at y equals f of negative x. So again, one more time, same functions here. So we have 0, 1, and 2. Go ahead and plot that square root function one last time. I missed it. There we go. All right, and now, right, we know that our y's are still the same, but we're going to look at what is the effect that this negative has on x in here. Okay, so if we want to take it, solve it like we did, let's put in our outputs to find the inputs. We'll say 0 is equal to the square root of negative x. Square both sides, and x is still 0. That's fun. Let's do 1 is equal to the square root of negative x. Square both sides, we get 1 is equal to negative x, so x equals negative 1. And then the last one there, we have 2 is equal to the square root of negative x. Square both sides, 4 equals negative x, so x equals negative 4. Put that in there. And when we graph this set, we have a point at 0, 0, negative 1, 1, and negative 4, 2. So you'll see what we just ended up with was a reflection across the y-axis. So when we look at our rule, y is equal to f of x, and then say y is going to equal f of negative x. This would be our points for f of x, but when we take it and we transform this, right, we're going to end up with, well, let's see, we had 0, then 0, we had 1, and then it's negative 1, and then 4 and negative 4. So what's happening here is these are going to be opposites. So we're going to say negative x, comma, y. If this was just like negative 1 times x up here and you were following the rules that we already learned, you know that when you got to the table, you'd have to do x divided by negative 1, and both of these actually end up equaling negative x. So that's another way to look at it if you didn't quite understand what we just did. Let's do a little summary of our transformations that we now know. So the first one, if I have y equals a times f of x, remember this is on the outside, so our new points would end up being x, comma, a, y. The next one, this one, a is on the inside, right? So we're going to end up saying here, our x value is going to be divided by a, right? Remember, it's like the inverse operation. And then we're going to have just y left over. For the third one, we have f of x minus h. Well, we know then that x minus h is like saying x plus h, and then comma y. So these two have those inverse relationships because we're dealing directly with the x values. Right? So what I mean by that, one more time, if this is a times x, we see x divided by a here. If we see on this one x minus h, that means we have x plus h in there. Let's move on to the next couple. We have y equals f of x plus k. That's our vertical stretch. So our points would be x, comma, y plus k. The next one we have here is going to be y equals the opposite of f of x. So we're going to say x. And then we're going to do a negative y. So this is going to flip it over the x-axis. And then last but not least, we've got f of negative x. And remember, we just said there with this one, we're going to end up with a negative x, comma, positive y. All right, let's move on. Use the parent graph of y equals x to the third and your knowledge of transformations to graph y equals the quantity of x divided by 6 to the third power plus 2. So our parent graph, y equals x to the third, we know that this table would be like negative 2, negative 1, 0, 1, and 2. We'll go ahead here and use the x to the third. So when I plug in negative 2 to the third, I get negative 8. Then I get negative 1, 0, 1, and 8. And let's just plot those on here. Negative 2, negative 8, negative 1, negative 1, 0, 0, 1, 1, and 2, 8. So we've got our nice little cubic function. Now let's focus on how does that change when we've got our transformations added in. All right, so what we've got to do here is identify, first of all, where these parameters are. But right now we have x divided by 6. So if x is being divided by 6, that means on our table we would need to multiply it by 6. So that's going to be a horizontal stretch. And then for our plus 2, right, that means we're going to take our y values and we are just going to add 2 each time. And again, just take your values from over here. Take your x coordinates, and you're going to plug them in for x. And then you're going to take your y coordinates, and you're going to plug them in for y. So you can go ahead there and work through this, and then check to see if you're correct when you're done. You should get negative 12, negative 6, 0, 6, and 12 for your x coordinates. For your y coordinates, you're going to be adding 2 each time. So negative 8 plus 2 is negative 6. Negative 1 plus 2 is positive 1. 0 plus 2 is 2. 1 plus 2 is 3. And then 8 plus 2 is 10. Last step here, let's just go ahead and plot them. Now I know negative 12, negative 6 does not fit on there. We'd say it'd probably be like somewhere back here. But then we have negative 6, 1, 0, 2, 6, 3, and then we have 12, 10, which would be another one that would be off. But hopefully you can see the shape of what's happening here, right? This one, because we were dividing by 6, it was horizontally stretched 6 times. I don't even know if I spelled horizontally right there, but so stretched 6 times, and that's why it's so much wider than the graph on the left. And then you can see the plus 2 when it's been moved up 2 units there. All right, let's move on. All right, on to our last problem. Given the graph of y equals f of x, graph the following. So we're given a couple transformations that they'd like for us to do. Before we do that, let's come up with the points that are on this original graph at the top. And we'll just pick out these points. We'll say that we'll use this one, this one, this one, this one, and that one. So when we do that, we've got negative 5, 0. We've got negative 1, negative 2, 0, positive 2, 2, negative 1, and then 4, negative 1. So to graph our transformations, we're going to have to make another table, and we're going to have to come up with the rules. So what you'll see out here is 1 minus f of whatever we have inside, right? So you could think about this as being like our stretch factor is negative 1, and then our k is positive 1. And you could write this a couple ways. You could either say, negative y plus 1, or you could say 1 minus y. Either one of those works. I'm going to go ahead and just use negative y. I'm sorry, 1 minus y. For our x values, remember, that's coming from inside the grouping symbols. So 1/2 times x is essentially x divided by 2, which means the inverse is going to be 2 times x. And now we're just going to take these x values and plug them in for x. You're going to double each of those. So negative 10, negative 2, 0, 4, and 8. And now let's deal with the y's. We're going to take each of these y coordinates and we're going to plug them in for y here. So the first one would be 1 minus 0 is 1. The next one would be 1 minus negative 2, which would be 3. The next one would be 1 minus 2 would be negative 1. The next one would be 1 minus negative 1 would be 2. And I think the last one we have 2 also, because those two numbers were exactly the same. Okay, so hopefully everybody was picking up on that. We were just putting our 0 in for our y, negative 2 in for our y, and so on all the way down. Let's plot those points. Negative 10, positive 1. Negative 2, positive 3. 0, negative 1. We have 4, 2, and 8, 2. And then we'll just connect them as we go across. Whoops, I went the wrong way. Don't do that. Remember, you got to hit them from left to right. That one, hit that one, we hit this one, and then it went over this way. Okay, so that is our first graph. You can see that it was definitely flipped or, reflected across the x-axis. And it looks like it was horizontally stretched as well. And then let's just do the last one. Okay, with our last one, let's go ahead and point out what we've got. For on the outside, we have 1 plus 2 times f of negative x. That's just simply going to be 1 plus 2y. And then this negative x, remember, is just going to give us another negative x. Let's go ahead now and use those points and plot them as we need them. So one more time, you're going to plug in these x values right here and for the x there. So you're just taking the opposite of each of those values. That would be 5, 1, 0, negative 2, and negative 4. And then we're going to do the same thing with our y's. So we plug in 0, we're going to have 1. Let me find my pen again. When we plug in negative 2, we have negative 3. When we plug in positive 2, we should have 5. Right, when we plug in negative 1, we should get negative 1, and then another negative 1. And all you need to do now is plot those points. So 5, 1, 1, negative 3, 0, 5, negative 2, negative 1, and negative 4, negative 1. And as we connect it, as we go from left to right,